Hi, I'm Alan Ross. I'm the managing editor of APC Media and APC Technologies. We are at the Mcvey 2023 Grid of the Future Symposium. And these interviews are with the leaders at Mcvey and the leaders of the industry. Hope you enjoy. My next guest is Mark Mcvey. Mark, welcome. Mark he's an ET technical specialist. He is with Dominion Energy, correct?
Yes.
And I understand that you and I went to tech. We went to the best tech schools, yeah.
We did. I had a great career coming out of Virginia Tech.
Oh, no, I'm at Georgia Tech.
No, Virginia Tech. That is the technical school.
Well, I went to Georgia Tech, so I got you there. I know we have the two best technical schools in the South, probably in the country.
Well, we traded professors back and forth.
So, yeah, right. Anyway, good. Well, thanks for joining us. Mark, first of all, tell me a little bit about your background. How did you get into the power industry? Why did you get into the power industry?
Well, it was one of those things that I was taking different courses when I was in school, and power just seemed very interesting to me. I did very well at the courses, and it intrigued me, being able to provide energy. So that was what I did coming out of college. It was funny because my dad was the chair of the EE department at UVA, a professor. Okay. And he told me that, why would you want to go into power? All the problems have been solved 50 years ago. Now, he has since apologized to me years ago, but it's been just a wonderful time. I've spent 40 years in the industry coming out, and almost every 5 years, I have seen innovations that have just kept my interest up in what we do. It's been rapidly changing.
That's what we're going to talk a lot about. But the first question I got for you, if your dad was the head of the EE department at UVA,
yes.
How did you end up at Virginia Tech?
They have a different philosophy. If you want to hire engineering managers, you'd go to the University of Virginia. They were heavy in the humanities.
Yeah.
But if you wanted to build and design stuff, you went to the technical school. And I'm a real hands-on guy. I wanted to build things. And so I went to Tech, and several of my professors had actually my dad was their advisor at Tech. So, so I had good crossover between the two.
That's great. That's a great explanation of the difference between because you think EE, it's the same thing. It's not. There are that. And interesting, when you were in it, there was a lot of people going into electronics and instrumentation, all of that. Not a lot of people going into power engineering, whereas now in the tech schools, it's sexy again because young people want to make a difference. Yeah. And we can make a difference in the power industry, right?
Yeah, and I actually had a dual major. One was in power systems, the other was in control theory. And it just so happens that that's coming to light in what I do today. It was fallow using that part of my degree for a number of years, but now it's very relevant in the electrification that we have going on in the industry today.
So there is a lot. You said like every 5 years you get new innovation. I think we are at the most innovative time for power systems because we have the most problems. We're trying to solve decarbonization as a problem. We're trying to do decentralization. We're trying to do digital. So we're trying to do all these things at the time that we have war, pestilence, and all kinds of weather events. I don't think we've had that much pressure on change in the power industry since I can remember, all at once. What do you think some of the main challenges are that we're facing right now?
Well, it's the grid transformation. Some of it is on the generation side. We're looking at renewables heavily for the decarbonization, all of those decarbonation aspects, but also the customer loads and expectations are changing. Yeah. When I was growing up, if we had an outage out in the country, we might be out of power for a week. It really didn't negatively impact our life. We were prepared for it. My parents had dry ice in the freezer, and we had enough spare gasoline that it wasn't a big problem. But today, nothing moves in our life without electricity. You can't get medicine. You can't get fuel. Yeah. You can't get groceries. I mean, most people don't can food anymore. Every 2 days, they go to the grocery store and they bring home whatever they're going to get that night. And so the reliance on electricity and the expectations are much greater, even in the last 10 years, the expectations and the technology for resiliency and quality of service are greater than they've ever been in the 40 years that I've been doing this. And that's what I see is the big challenge as we do the grid transformation to also maintain the expectation of these customers, which is much higher today than it was when I started out.
And also, and I was just talking to somebody, and he mentioned the fact that many customers are becoming prosumers, not consumers, because they have an electric car in the garage and a battery and a rooftop solar. So they are now, you're going both ways with them. So it makes a much more complex grid, right?
It is.
What is an ET? You're an ET equipment, right? Specialist.
Equipment and technology.
Okay.
It's in the transmission group. It's hard to explain what I do because I'm basically an advisor consultant across all the business groups.
Right.
I've had an eclectic career, spent a large amount of time on the distribution side of things.
Okay.
But also substation transmission. I do a lot of work on the generation side. We have a group that focuses on renewables. So that's solar, nuclear. So a lot of times I have a background in system protection, equipment modeling.
Yeah.
So I do a lot of problem solving in there. But also I'm looking at new technology. So I'm involved in IEEE, IEC, and of course, CGRE, which gives me a viewpoint not only domestically, but internationally to see what's going on. I just came back 3 weeks ago from Australia, from the CGRE meeting there, and they're advanced compared to where we are with the grid transformation, much higher renewable input. And so I learned from them about the technologies and things that they're doing with hydrogen as a combustible fuel, things that they're working at with technologies, and not just a matter of changes in technology, both for generation, but there's also new materials. We're changing from porcelain and glass to cycloaliphatic materials for insulation. The interrupting materials, when I started out, we had oil in the breakers, oil in the transformers. Then we went to SF6. Well, now SF6 has been identified as a greenhouse gas. So we're transforming again and looking at different compounds and gases to be able to do short circuit interruption and to be able to still shrink equipment down so we can put it where we want to go. And so it's not just the generation portion of it, it's the entire aspect. A big part of it is the change in data. We're digitizing everything and collecting that data that's allowing us to move from what we used to be in time-based maintenance. It's like, okay, well, it's time to go ahead and maintain that breaker or that transformer, to moving to condition-based, where we do monitoring and pull that data back, to now taking that data and transforming to reliability-centered maintenance. So it's across the board. It's not just, you hear, and renewables is a big portion of that, but also the transformation across the board, both in data, materials, and also the workforce. The workforce, the needs are much greater. They need a bigger skill set. When I got out of school, you just need to have the power piece, but these people need to know economics. They need to have business sense, and they need to be able to communicate. Engineers are not good communicators.
I got to tell you, you've kind of covered the gamut of everything that's going on, which is brilliant, because I just recently I had the pleasure of moderating a power panel with subject matter experts on SF6 from GE, Siemens, and Hitachi. And the three of them were talking about what they were all working on. It's a similar solution, but not a same. But the point of it was amazing collaboration between three competitors, to be able to solve a major problem. Before we got on, we were talking about something, and I believe that this inverter-based system that we're building, because of the distributed energy, prosumers, all of that, is creating a lot of transients and harmonics in the system at a lot of different levels. You were mentioning how you solved, I'm going to say a problem. Maybe it was one problem. Maybe it was all the problems, but you solved the problem with harmonics in the transmission system, right? At Dominion. Talk about that.
Well, they're growing, and we talked about the monitoring that we're putting in the system, and so we have visualization of that. The problem is at the transmission level is dealing with those as they come on, as the short circuit levels go down because the renewables don't provide that to the system. You used to get cancellation in the system, so it wasn't as big a deal. It didn't bubble up to the transmission, but in some extreme cases. And then typically you could do some type of fixed filter. But the advent of using power electronics like static var compensators or StatComs is a big part of it, is that one of the services that a StatCom can provide is to do harmonic cancellation. And so it's something that you can turn on and off depending upon the time of day, or as if you see threshold levels, it can help you mitigate that until a permanent solution can be found in the system.
Yeah.
That's one of, I guess, the biggest concerns that I have with renewables, and not that they're carbon free.
Yeah.
They don't provide all the services that the old generation did, and the customers' loads haven't changed to adopt just to a renewable type. So we have to put those services back into the system to make everything work. And that's where a StatCom is fabulous, because it's like a Swiss Army knife. It has an ability to provide a lot of those services and being able to deal with harmonics. I mean, one of the problems that we had during COVID, was remote learning for kids. Was it turned out the switching frequency for some of these distribution solars were right at the digital subscriber line frequency. Remote places don't have, say, fiber. They're still using DSL to get their internet. So the kids couldn't learn because of the harmonics that were being impressed upon the system. Wow. And the internet didn't work. So working with the developers to mitigate that, either to change the switching frequencies or to provide some type of blocking for the grounding to keep that out of the system, was a challenge. Now, in the future, that we'll have that figured out, we'll have that mitigated, but we're not quite there yet. But we're trying to pile this on as quickly as we can because of the concerns about the growing amount of carbon that we have. And so that's one of the biggest challenges that I have as an engineer, is trying to provide these services when we're not quite up to speed at to be able to replace like for like in technology.
Yeah. Well, you said engineers are not effective communicators, or you're an incredibly effective communicator. So I think last question I've got for you. You mentioned Seagray Australia. We're at the Seagray Symposium here, the U.S. Seagray. The value of Seagray to you?
It's tremendous, and it's tremendous to my organization, because I'm dealing with people that are the best at what they do in the world. People that do what I do for other companies that are those top people in that field, whether that's transformers or I'm involved in substations. But being able to network with those people and to learn from them, you can learn so much in your small group. You think of competitors that want to go to the Olympics. Well, they're as good as they can be in their high school or their state, but then they compete nationally or internationally. Seagray is very much the same type of environment that allows us to learn and grow outside of our own small system. I'm able to learn from guys that have already made the leap and the problems that they've encountered. I always tell people I don't have to know everything. I just have to know who to call. Yeah. And so the networking aspect is a good part of that. But the introduction, it is a technical organization, and there are some fabulous papers. I mean, these are worthy of thesis, many of these brochures that you see that are available. And it's beyond, say, what you do with IEC and IEEE, and a lot of those aspects are focused just around single topics for equipment. But Seagray is more geared towards the user end and the supplier end. So asset management is a big part of what we do in developing theories and programs, restoration of service, wide area, black start philosophies of what people are doing in our industry. So you really have the opportunity to be on the cutting edge of what we're doing more so than some of the other technical groups
Right.
that are out there. And it's a great place for our young people to network and learn. So we try and get some of our young engineers, the new NGN network that we started.
Yeah.
These are going to be the leaders and the executives of the future. And so having the ability to start them out quickly and do that networking, putting a mentorship together. When I started in the industry, there was really not a mentorship to figure out what your career was going to be. So I wandered around in different groups within the utility to kind of figure out what it was that I wanted to do. And they really didn't have somebody guiding me. But that's the value in Seagray, is both technically and socially, and allowing me to grow and figure out over my career what I wanted to do. It's been quite enlightening and wonderful.
Great spokesman for the organization. We're going to be interviewing a couple of NGNs here because
Good.
I agree with you. We got to get them engaged and involved. Mark, brilliant interview. Thank you so much for joining us. I want to do this again. It may have to be over a Teams call, because if we have a certain subject we want to talk about,
Sure.
I'm going to give you a call on it.
Very good. Thank you.
Okay, thank you.